now we are looking at the last question, which is a small sample hypothesis test and confidence interval. All right. Okay, so let's see. Okay, so I think that the number of pizza slices that people eat in a month in Gainesville is 7. So the mean amount of pizza slices is 7. And I want to see if the true value is above 7. Okay? And I find that x bar equals 8.4. So I collect a bunch of data, specifically 17 people. Standard deviation of 2. Okay, now I want to find my test statistic. And the way we do that is so can we assume normality? Yes or no? Okay? No, we can't. Okay? However, when we have a small sample, we can use the t-test. Okay? Now, it wasn't directly stated in the problem, but if you're in stats 2 and you can't assume normality, then you're going to have to use the t-test, and it's going to have to be assumed that these observations were from a normal distribution, which is in fact true most often. All right, for a population mostly probably normal. Okay. Okay, so how do we do the t-test? Pretty easy. Okay, x bar minus mu naught over s over the square root of n. So we find 8.4 minus 7 over 2 divided by the square root of 17. Okay, and what that turns out to be divided by 2 square root 17 is 2.88. All right. 886. Okay, so our t-value is 2.886. Okay, and what does that mean? So I'm going to draw my t distribution over here. Okay, the center at 0. So it basically looks like the normal, but they're slightly different. Okay, now what my observation is 2.886. And I want to find the values. I want to find the probability of being at 2.886 or more extreme than that. Okay, so I want this probability. Okay? Or alternatively, I could find this one. That doesn't matter. Because the t is completely symmetric about the mean. Okay? Now, in order to see whether or not our p-value is greater than or less than, what do we have to do? We have to compare it to the table value, okay? Which is, remember, you have t of alpha over 2 of n minus 1, okay? Degrees of freedom. Because the t always has n minus 1 degrees of freedom. Not always, but most of the time. Okay, so we want to look at t of 0.975 of 16, okay? Okay, so this is the t, this is the right tail, 0.025. This is the right tail probability, and this is the same thing as the two tail probability of 0.05. And if you look at your t table, it tells you the confidence level, which is the same as the alpha level, which is 0.95. So if you look at the column of, if you look at the 95% column, you go down to DF, you go down to 16, you're going to find 2.120. Okay, and now we compare it to T star, okay? Okay, so this is 2.120. Okay, so this is the area of 2.120. Okay, notice again that this is 0.05, 0.025. And this is a smaller area, which means that this is the whole thing, and this is a smaller amount, which means that t star is, so we have greater than t at 16, which means that our p-value is less than 0.05. Okay? Okay. Oops. Yeah, or I'm sorry. So this is 0.05. This is point. Okay, so this implies that our p-value is less than 0.05, and we reject. Okay. So we have enough evidence to say that the mean value of the number of pizza slices a person eats in a week is, in fact, greater than 7. Okay, now if we want to create a confidence interval of these values, okay, all we have to do is x bar plus or minus t times t s over the square root of n. Okay, so that's 8.4 plus or minus. The t value is 2.120 times 2 over the square root 17. Okay, which gives us the value 7.371 to 9.2428. Okay, and notice this interval does not contain the number 7. Okay, it's only greater than 7, strictly greater than 7, which means that it supports our conclusion of rejecting H0, and we are successful. Okay, and to find you can't really find the exact p-value concerning this, but you can look at the ranges of values. So what you do is you just look in your table and find the two p-values that your answer falls between. And if you look, it's between 0.005 and 0.01, so that's the range of p-values.
The Teaching Center, UF's Learning Resource Center.